All right, our next presenter is Chris Anderson from 3D Robotics, which is also a sponsor, and I'm sure everybody's been back there and looked at their equipment. So I'd like everyone to welcome Mr. Chris Anderson.
Thank you, Patrick, and congratulations again on putting this together. This just gets better and better. Many of you may know me as the founder of DIY Drones, and I kind of wear two hats. I am part of a big open source development community that operates under DIY Drones and ArduPilot, and created the leading open UAV platform. And I also run 3D Robotics, which is a manufacturing company that makes things like Pixhawk and APM and the vehicles that you can see in the back. What I'd like to talk about today is more on the software side. Over the last 5 or 6 years that I've been involved in this, we've gone from getting robots to fly, which was hard enough, to getting them to fly well, adding features and functionality, making them easier to use. And now we're going beyond that. Now as we start to work with them, we're starting to think more in terms of the entire platform. The platform going all the way from the cameras and other payloads up into the cloud. And the model we use for this is Android, really as close as possible. We look at what Google and the Open Handset Alliance has done with Android to take it from from right down to the various sensors on the cameras and other devices, all the way up through the app stores and cloud services and big data and all that. And we are collectively with our community building something that is designed to be as powerful and flexible as Android for flying vehicles. And what I'm going to do today is just sort of share with you a little preview of where we are on all this and the model behind it, and then talk a little bit about the foundation, the Drone Code Foundation that we are about to announce and set up, which will be the open source organization that holds the dev teams and will ensure that the development of this platform accelerates, continues, and is protected by open source, an open source institution that will allow all of us to use it with clear guidelines and IP protection built in. Just to kind of remind you how Android works, this is just Android, the one that's in your phone or other devices, and you have at the core, you have the Linux kernel and the basic libraries. And then on top of that, there's these system applications and the skins and the user interfaces, and then the Google Play and the App Store and the apps themselves, and then all the cloud services that are built around this. And some of these things are, at the core, these are classic open source stuff. And and as you move up, you have a choice between companies that choose to make open source versions and companies that choose to have closed source versions, and that's all part of the ecosystem. It's compatible with both. I wanted to then give you the analogy with the drone code core, which is basically what you know as the APM flight code, the Pixhawk flight code. And it starts at the core with the operating system, which is an open source system called Nudex, and the flight code. Then there's these companion computers that work with them that can do everything from Python scripting. And these are the Linux based devices. These tend to be quite fast processors that can add more intelligence, machine learning, very sophisticated on-the-fly onboard image processing. Again, bringing in things like Python scripting as a easy-to-use and safe way for regular people to control these vehicles without having to get into the autopilot itself. Then you move up the stack, and you have the communications layers, which is Mavlink and the underlying radios. This is all open. Then you move up higher to the applications that run on laptops or mobile or beyond. And so that's the core. And then around that, you have all these opportunities for people to build products and services that work with it. There can be other companion computers and image processors that work on board that communicate in this stack via via protocols like Mavlink. There could be different skins and user interfaces. Again, in the same way that your Google phone, you can either get one that's pure Android, or you can get one, a Samsung one or an LG one, etc. This is an opportunity for other companies to add value and put their own user interface if they want. We have our open communications layer, but there's no reason, and there are already people developing encrypted communications layers layer that are based on this standard but designed for different applications where encryptions are required. There's apps that anyone can make, much as Parrot has shown us with all the apps that work the Parrot AR drone. We're encouraging other manufacturers and innovators to create apps that are specialized for certain purposes or markets. And then we get to the cloud, which is the really exciting part. I was delighted to follow the our drone deploy friends, because their vision of how the cloud, the big data opportunity, is really where we're going next, is one that we share entirely. I just wanted to give you some glances of how this works. So again, just to show you the stack from another perspective, when we say we go from the iron to the cloud, we mean not just the sensors, but also the payloads. Like many here, we control the cameras, or more to the point, the cameras control the vehicle. We use, like everybody else, we use Canon S110s with the firmware replaced. But what's great about this ability for the cameras to not only have intelligent software on board, but in communicating with the autopilot in real time, is that the camera can control the mission. The camera's reading the histograms of the pictures in real time and can adjust the mission to capture the right image at the right time with the right contrast, the right shadowing. And so this sort of image-driven mission, this true autonomy led by the camera itself, is the kind of thing you can do when the platform extends all the way from the camera up into the autopilot and beyond. Then you have these companion computers. The drone deploy folks have shown you their companion computer, which basically takes Mavlink data and sends it out through LTE networks. But there's also other companion computers that will do Linux-based computing, store data, integrate the data from the camera and the data from the autopilot to get high resolution and very precise metadata to allow stitching software to work better. And then you start moving up even higher into the computing that's being shared between the vehicle and the ground and laptops and other computers, and then the vehicle and the computing that's being shared between the vehicle and the cloud, as the drone deploy folks show you. By having a stack, by having these protocols and data standards that go from camera all the way to the cloud, we're able to choose where to do these functions. We're able to choose how to load balance the computing challenges so that you get the right combination of what's on the vehicle, what kind of bandwidth you have in your radio spectrum, what kind of computers you have on the ground, and what kind of computing capacity you have in the cloud, and just use the right combination for the job at hand. This is what's possible when the drones become part of the Internet of Things, if you will, and you have these common protocols, this true platform approach that allows you to move from one part of the code, one part of the platform, all the way to the rest. I wanted to show you some glimpses, and this is the first time these have actually been shown. In about a month, we're going to announce our first APIs and web services layer as part of this platform, and it'll probably be running under the name DroneShare. But these are just some early screenshots of what's possible. So the first stuff, and it's very similar to what Drone Deploy is doing, and I think we're very complementary in this respect, and we would like lots of web services company to offer competing services. We think of it on a consumer level as a little bit like Runkeeper or Strava, but for drones. You can see vehicles in real time, your own and others, anybody who opts in. You can track individual missions. You get this performance data, you get the telemetry data, which is also not only being shown, but also recorded for later analysis. You can do data log analysis after the mission. You can do diagnostics. What's great about it is we have something along like 10,000 flights already recorded in our web services platform, and this is allowing us to do machine learning and big data analysis of these, so that we can not only tune the aircraft, often in real time, for better performance based on the flights of others, but we can spot problems before they happen. We can spot bearing issues with motors, vibration issues. We can tell the users about things they don't know about their own vehicles. And as we design vehicles going forward, we don't have to guess at what people want. We can actually measure people's flight patterns and optimize our vehicles and code and hardware to accommodate those. Like everybody else, you can include the data, from the imaging devices along with the flight. This is the sort of log analysis. You can upload your logs, and it'll automatically give you diagnosis about what's going on, about how to tune your vehicle for higher performance. You can see other vehicles and their missions, anybody who's opted into the platform, and you can do fleet management. Much like others that you've seen, especially Drone Deploy. This is the ability to have multiple vehicles, to be able to kind of spot them, spot what's going on, look at their performance without having to have experts on the ground. You can let the cloud do the work of aggregating the data, then assign a fleet manager to examine the performance of any vehicle, and have just technicians or even end users using the vehicles on the ground, knowing that the cloud is keeping track of all the stuff all the data that's required. So we think of this as an ecosystem, just in the same way that all black boxes, all phones look the same, but the phones that have the biggest ecosystems are winning. The reason that Android is doing so well right now is because it's got the biggest ecosystem, from the hardware partners to the different hardware configurations, from glasses and watches to phones themselves, to the apps that run on it, and to the services beyond. And these are just some of the companies that we're working with. Many of whom are here today. That give you an example of how far this can extend and what specialty software can be brought to bear once you take an ecosystem approach to a drone platform. By being open, you don't even need our permission. You don't have to do a deal with us. Anybody can use our APIs, our data, our code, and I'll talk a little bit about how that process works, but we're committed to open innovation, and that is really, I think, what's, the 21st century lesson of moving fast is moving together, making it easy for people to add value and build companies around a platform. And one last example before I get into the foundation itself is our friends at Skycatch, who are based here in the Bay Area. What we love about them is that they have this ground station that does battery change and data exchange. And it's an incredibly sophisticated ground robot, and it's designed for automated functions, things like facilities management or security, or anytime you want just these things to do repetitive missions unattended. They are adding a lot of value on the ground with this device, but they wanted to work with an open platform, and so it's based on the Pixhawk platform. And we love how they're able to target industrial applications that we, the community, couldn't reach by extending the platform to these really creative new uses. So as I mentioned, we're going to be launching the Drone Code Foundation soon. We've hinted at this in the past, but we're now moving it forward. This is going to be essentially the institution that holds the software and the open innovation community that we're already working with under places like ArduPilot and the APM dev teams. And this ensures that it has a clear governance structure, transparent processes, criteria for membership that go from free to corporate membership, levels of service. We can protect people in terms of indemnification. We can hold copyright if necessary. This is exactly modeled after many others that came before us. We're very lucky to stand here on top of almost 20 years of open source development. But we work very closely with the WordPress Foundation and Matt Mullenweg and his team, Open Compute Foundation, which takes the data center software and hardware and puts it in an open context, and the Linux Foundation, of course, is the model for all of these. So this is largely to ensure that the development teams get bigger, that they're healthy, that they're protected, that they're funded, that the open innovation that they built is protected as well, that there's a standalone nonprofit organization which is 100% focused on open innovation. And we will be a member, we 3D Robotics will be a member, many other companies will be members as well, again, modeled after Linux Foundation, for example. The primary contributors are Intel and IBM, who benefit from Linux, and we all benefit from their contributions. So it's time. We have now gotten to the stage where the development is mature, the community is healthy and vibrant, but we've been a little loosey-goosey about some of about the transparency and the mechanisms of how this runs. Open source is confusing to many, but we stand on the shoulders, as they say, of giants. So it's time to create something that is official, that is transparent, that has a clear governance structure that is not around one single company. The licenses are the ones we've been embracing to date, Creative Commons, BSD, GPL3, and beyond. We're a big tent. Any open source license I think almost all open source licenses have a place in this. And if people want to work with the code in a closed source context outside of the foundation, some of these licenses allow for that, such as BSD. The community itself is large and healthy. As many of you know, DIY Drones has more than 53,000 members. The APM code base, which many of you use, we actually have no idea how many users it has because it's open source. You can get the hardware from cloners, from partners of various sorts. We sell tens of thousands of boards, but I think we probably have a minority share of the market that we created. And when we look at the statistics, we see 100,000 plus uses, and we have no idea how many users that is, but it's clearly big and growing. And our development teams who work on GitHub, you can just see the volume of commits. That's like 150 commits a day, just on the flight code base alone. So the vibrancy of this open innovation community is really just extraordinary and heartwarming to see, and I'm pleased to say that we're now going to put it in a very good home with this foundation. Expect more details on this in the next month or so, but we will hope that a year from now I can count most of you as members of the foundation or using the foundation's efforts, or otherwise just benefiting from the open innovation model applied to our own industry. That's all I got. Thank you very much. We have time for some questions, Patrick tells me.
Yes. Any questions, or did you nail that one shut?
Any questions? Okay. Thanks again.